Hi friends, welcome to Simplify Maths. Today we are going to learn Congruence of Triangles, Chapter 7, Exercise 7.2 for Class 7. First question, which congruence criterion? Criterion means whether it is SSS congruence criterion or ASA or SAS or HS. This belongs to criterion, congruence criterion. So which one these triangles belongs to? We are going to find. So which congruence criterion do you use in the following? We will see. They have given two triangles, right? ABC and DEF. Also given conditions. AC, this AC side equal to this DF. So one side. Both are equal. Again, AB, this side is equal to DE, this side. So equal. Next, BC, this side is equal to EF, this side. So it is obvious, right? All the three sides are equal in both the triangle, means it belongs to SSS congruence criterion. Next, B. Two triangles they have given, PQR and XYZ. Given, these are all given coordinates. See here, ZX, this ZX is equal to RP. So side is equal. Next, RQ equal to ZY. This is RQ. This RQ side is equal to ZY. This is S. Next, angle PRQ. See, center vertex is the where angle is formed. So center vertex is R here. So angle formed here. PRQ. Similarly, XZ. So here only angle formed. So this is angle. This is same as this PRQ is same as angle XZY. So see here, and by automatically it formed SAS. SAS criterion. So this is called, belongs to SAS congruence criterion. Side angle side. Included angle, not any other angle, right? Included angle, side, in between side, one angle formed means it belongs to SAS congruence. Next question, C subdivision. See, LMN and FGH, two triangles they have given. Angle MLN, so L only angle formed, MLN. This is MLN. Next, FGH, here one angle, same, both are same. Next, NML, this is NML, here one angle formed, NML. This is corresponds to GFH, here one angle formed. ML, this is ML, right? Side, this is ML. This side is equal to FG. This is FG. This side. See, two angles formed in between two equal sides in both the triangles formed. So it belongs to ASA, angle side angle criterion. ASA, angle side angle criterion. Easy, right? If you do like this, you can easily, automatically it will form, whether it is ASA or SAS or SSS, whatever. Next, EB, given triangle. These are right angles. See here, right angle formed here. Right angle means 90 degree. That means a perpendicular line to the baseline. Angle formed here is 90 degree. So wherever angle formed, here also it is 90 degree, both sides. So see here, EB. Where is EB? This is EB. It is, both are right angled triangles. Okay. Right angle formed at A and C. Angle A is 90 degree. Similarly, angle, this is C, is 90 degree. So angle formed. R over, correct? R is over. Now, this is hypotenuse. This EB is equal to DB. So hypotenuse is also over. Next, AE side. equal to BC. This is also a side. So R, this is 90 degree means right angle, right? RHS, it belongs to RHS criterion. Right angle, same hypotenuse and same side, both the triangles have. So it belongs to this RHS criterion. Next, second question. You want to show that triangle ART is congruent to triangle PEN. Okay. Triangle ART is equal to triangle PEN. Is congruent to. If you have to use triple S congruence, then you need to show. Triple S means all the three sides should be equal, right? So, AR must be equal to, order should not get changed. Keep it in mind. ART means PEN, same type it should exist. So, this side is congruent to PE. AR congruent to PE. Similarly, RT. This side is congruent to EN, right? EN. Similarly, AT congruent to, easy, right? PN. That's all. See here, PN. B. If it is given that angle T is equal to angle N, and you are to use SAS criterion. SAS means side angle side criterion. You need to have RT. This RT is, see here, angle T. They have given this angle is equal to this angle. If we are going to use SAS means this must be the included angle. See, angle is in between two sides. So, this RT is equal to this EN, correct? This side should be equal to this side. So, RT is equal to EN and this side PN is equal to AT, this side. So, side angle side PN equal to AT, that's all. Next, if it is given that AT is equal to PN and you are to use ASA criterion, you need to have. If you are going to use ASA criterion, already they have given. Just think this as a new triangles. They have given AT is equal to PN. That means side they have given. Side they have given. Okay. We are going to use ASA means this must be the included side. So here one angle. In between two angles only this side should come. So what we are going to do, this angle A must be equal to angle P and angle T is equal to angle N, also given AT is equal to PN. So, angle ASA, see here, ASA equal. So, correspondence. So, if they are equal means it belongs to ASA criterion. See here, RAT. Otherwise, we can give simply angle A is equal to angle P. Otherwise, RAT or TAR, this vertex, wherever angle formed, that is the main vertex we need to show in between. RAT. Here, EPN. Similarly, PNE. N only angle formed. Here, ATR or RTA, whatever. Otherwise, simply angle A equal to angle P, correspondence. So, angle T corresponds to angle N. Also, given side AT is equal to PN. So, it belongs to the criteria ASA, angle side angle. Third question, you have to show that triangle AMP is congruent to triangle AMQ. See, in this figure we can see two triangles, one triangle and next second triangle. AMP is congruent to AMQ. In the following proof, supply the missing reasons. See here, PM is equal to QM, right? Both the sides, PM is equal to QM. Reason is, it's already given. So, it's given. Next, angle PMA. Here one angle formed, right? This angle is equal to angle QMA. it is also given. Reason is given, just given like that, that's all. This is the reason. Next, AM equal to AM, because it is common for both the triangles. This AM is common for this AMP triangle also and AMQ triangle also. AM equal to AM. Why it is equal? Because it is common. Next, triangle AMP congruent to triangle AMQ. Why it is congruent? Because, listen carefully, side equal, angle for both equal, side. So it belongs to SAS criterion. According to SAS criterion, okay, SAS criterion, both the triangles are congruent. Fourth question, in triangle ABC, angle A equal to 30 degree, B equal to 40 degree, C equal to 110 degree. In triangle PQR, angle P equal to 30 degree, Q is equal to same degree like ABC. Okay, 30, 40, 110 degree each. As student says, the triangle ABC corresponds to, congruent to triangle PQR by AAA congruence criterion. That means angle, equal angle congruence. Is he justified? Why or why not? Angle A is equal to 30 degree, angle B equal to 40 degree and angle C is equal to 110 degree. Similarly, in triangle, this is triangle ABC. Now we are going to do PQR. Angle P is equal to 30 degree, right? This is 30 degree. Angle Q is equal to 40 degree. Angle R is equal to 110 degree. But see that angles are same, right? All the angles are same, corresponding angles. But the length of the triangle is different. So it is not congruent. Both the triangles are not congruent. So the answer for this question is not congruent, because if it is congruent only, then one triangle can, if we cut this triangle and place it over it, it can overlap the other. It can hide the other, but it won't do, no. See here, this is 110 degree, right? This is 110 degree, but I have extended this to little extent. See, for degrees we can extend the line to any extent, right? Same 110 degree. This is 110. I have extended line till here. This is also 110 degree. 110 degree. See here, but I cut the line inside the protractor only. Here only, this line. So while making angles, we can extend our lines or we can short our lines. So using AAA property, it is not possible to say triangle ABC is congruent to triangle PQR, because the lengths are not same. If the lengths are same, then we can say that both are congruent. So AAA alone can't work out for congruence. So it needs the sides also. Either it must be SSS or SAS or ASA or RHS. Fifth question. In the figure, the two triangles are congruent. The corresponding parts are marked. We can write triangle RAT is congruent to this triangle only, but we need to give the coordinates properly. RAT is congruent to whether NOW or WON or NWO. So in which way it is congruent, we need to show. We need to look for the correspondence here. Now we will see the correspondence. AT corresponds to ON. Similarly, angles formed are, see, if we place the angles properly, then it will nicely come. See, this vertex or vertex, no, R corresponds to W. Similarly, A corresponds to O. T corresponds to N. See, this 1 and 2 curves, 3 curves indicate same type of angle. So one curve belongs to same angles and 2 curves belongs to same angles. Both are same. 3 means these angles formed here are equal. So R corresponds to W and T corresponds to N. Next, O. A corresponds to O. RAT corresponds to WON. If you keep it like that, if you keep this upside down, it will be exactly equal to RA2. This WON is we can write triangle RAT is equal to triangle WON. That's all. Sixth question. Complete the congruence statement. Triangle BCA congruent to another triangle is also there, no? BTA. We are going to find this BCA is congruent to which triangle? So it's easy. BCA. So it starts from B only. Then only it will another triangle. This triangle will superimpose. If you fold this triangle and keep it here, it will be same. So this triangle BTA is congruent to this BCA, right? If you fold this part and take this over here, this BCA will get superimposed by BTA. So triangle BCA is congruent to BCA. Otherwise, these two sides equal and these two sides equal. So BCA, similarly BTA, sides equal, no? Sides here also one side. So BTA. In QRS triangle, in which way it is congruent to this PQT triangle? We will see. It's very easy only. QR. So come here. Single, this both are equal, no? QR is equal to PT. Over. So PT. QR, S. S is 3 lines. 3 lines should match with this 3 line. So T, P, next Q. T, P, Q. These denotions shows that these are all equal sides. 1 line means these two sides equal. 2 line means this QT is equal to QS. This 3 lines means PQ is equal to RS. So TPQ. QRS. 1 line, 3 line. So 1 line, 3 line. TPQ. Right? QRS. 1 line, 3 line. QRS is congruent to 1 line, 3 line. TPQ. That's all. Seventh question. In a squared sheet, draw 2 triangles of equal areas such that first, the triangles are congruent. In one way it should be, we should show the triangles are congruent. Similarly, in another squared sheet, if we draw 2 triangles of equal areas such that we need to show the triangles are not congruent. What can you say about their perimeters? See, I made one square with a 4 centimeter everywhere, with a 4 centimeter as a side. Okay. Now, diagonals from D to B are diagonal. ABCD is a square, DB is a diagonal. Similarly, AC is a diagonal. In a square, we all know that diagonals are always equal and bisect each other. Bisect means this must be the exact midpoint for both the diagonals. So this is O. We are giving name for this as O. So this is the exact midpoint. All the sides are equal. In a square we know that, right? AB equal to BC is equal to CD is equal to DA, right? Similarly, this AC is equal to BD. AC is equal to BD. Diagonals are also equal. They bisect here. So, AO is equal to OC, right? AO is equal to OC. And this one, BO is equal to OD. We are going to consider there are 4 triangles here. Shall we consider these 2 triangles? This AOD and BOC. See here, I used different colors to show which triangles we are going to take. AOD and BOC. So we are taking into consideration triangle AOD and triangle BOC. Now we are going to show these triangles are congruent. So by which way we are going to say these are congruent? Let's see. See here, this AO, right? This AO is equal to OC. For this triangle in AOD, AO is equal to OC. AO is equal to OC. Next, BO is equal to another side. See, one side over this side and this side over. Again, we are going to do BO is equal to OD. From this triangle BO, from this triangle OD. Now, this side also over, equal, right? These are all equal. Next, AD is equal to BC only. And AD is equal to BC, side of the triangle, 4 centimeter, 4 centimeter each. See, this is also equal, these sides also. That means they are all equal. So, by SSS congruent criteria, we can say that these triangles are congruent. So, we have showed our first subdivision from 7th question. By SSS congruence criterion, this triangle AOD is congruent to triangle BOC. Now we need to take two triangles in the same squared sheet. Squared sheet means square, in the same square. We need to prove that even though it is in the same square, two triangles are there, means it is not congruent. We are going to prove the triangles are not congruent. Let's see. Let us give name for this as M. Okay. See here, PQRS is a square, right? Now, this QRS is one triangle and QMR is another triangle. So, two triangles. You can see two triangles, right? See, in this, we can see QRS is one triangle and QMR is another triangle. We are going to prove that these two triangles are not congruent. It's very easy. We will show. From M, I am going to draw a perpendicular from M. Perpendicular means a direct vertical line from M to the base. So, we will give name for this as MX. See, area means equal area. They have equal area. They are telling like that. See, in this also, all the sides I made with 5 centimeter each. So, all the sides are equal, outer sides. Now, what is the area of a triangle? Area of a triangle is half BH. Half 1 by 2 into base into height. Let's see the base. If this triangle, for triangle, see here, for triangle QRS, just listen carefully, for triangle QRS, what is the altitude? This is the altitude, right? For triangle QRS, whatever altitude is, if we are taking in this way, I am drawing just only this part, okay, QRS. So, if it is the triangle, altitude means from a vertex, if we are drawing a perpendicular line to the base, this is the base, correct? So, this is the base. So, SR is the altitude. Altitude is equal to SR. Base is QR. Right? Similarly, for triangle QMR, listen carefully. Here also, for this triangle, what is the altitude? Altitude is, we just drawn for this altitude, for this triangle, we just drawn MX. So, altitude is equal to MX. For this triangle, see, this is triangle QMR, right? For this triangle, altitude is MX. And base, what is the base? Base is equal to full QR, right? This is base. Here this is the base. This is the height. Height, base, QR. Now see one thing carefully. This altitude, this SR is equal to MX. Equal height, no? This SR is equal to MX. Equal height, right? Similarly, base. What is the base here? QR. QR is equal to, for this QR, for this triangle, QR is the base. Similarly, for this triangle also, QR is the base. So, both are equal. So, if base and height are equal for two triangle means it must have the same area. So, area over, area problem over. Both have the same area. But now see that this is a triangle with 90-degree angle. 90-degree angle, right? Right triangle. But see, this is not a right triangle. So, it won't fit into this triangle. It must be different. Both are not congruent. So, triangle QRS is not congruent to triangle QMR. That's all. We just proved. In a square sheet, two triangles, if we have taken like this, both are not congruent. Draw a rough sketch of two triangles such that they have 5 pairs of congruent parts, but still the triangles are not congruent. See, I have drawn two triangles. Okay, I am going to show you that 5 pair of elements are same, equal. But if it is equal also, I am going to prove that they are not congruent. I have taken two triangles, ABC and PQR. Let's do this. See here, all the angles formed, equal angles only formed in both the triangles. So, angle A is equal to angle Q, right? Next, angle B is equal to angle R. Angle C is equal to angle, now sides. AB. AB is equal to this two line mark. It indicates both are equal. PQ, right? PQ. Similarly, BC. This is BC. This single line indicates same side, same length side. BC is equal to QR. Now, for these two triangles, we have shown 5 pairs of equal elements, right? But see here, one important thing, these are all equal. This AB, this side lies between 90-degree and 30-degree. But in this triangle, P and Q, PQ, here it lies between, this same side lies between 90-degree and 60-degree. Here 90-degree, 30-degree. So it won't work out, no. If the angles are same only, they must be congruent by ASA property. So it is not congruent. See, by none of the congruence criteria is satisfied, as the corresponding sides and corresponding angles are not equal. See, corresponding sides, and if angle is equal, side is not equal. If sides are equal, angles are different. So, none of the congruence criteria is satisfied, as the corresponding sides and corresponding sides are not equal. Ninth question. If triangle ABC and triangle PQR are to be congruent, name one additional pair of corresponding parts. Which criterion did you see? See, two triangles they have given. Okay. So, by seeing itself, we can easily say it is a right angled triangle. Right angle formed here in B and Q. Also, they have given angle C is equal to angle R. They have mentioned it. Angle C equal to angle R. So, if BC, this line segment BC is equal to this line segment QR, if both are equal, it belongs to angle, side, angle category, right? Angle, side, angle, ASA. It belongs to ASA criterion. See, if BC is equal to, if I include BC is equal to QR, it belongs to ASA criterion, congruent criterion. 10th question, explain why triangle ABC congruent to triangle FED. See, both are right angled triangles. See, here 90 degree formed. In B here, in E. At E, 90 degree formed. Both are right angled triangles. So, first thing over. Next, the base angle. See here, in 90 degree. At the point B, at the vertex B, 90 degree formed. The base angle BC is equal to the base angle ED. Right? This is also equal. Now, R. We got R. In two ways, I think we can show these are equal. 2-3 ways actually. 90 degree given, base angles, base lengths are equal. Base lengths are equal. BC is equal to ED. Now, angle A equal to angle F. This is also equal. Angle A is equal to angle F. Next, if all are equal means this hypotenuse side must be equal only. This length also equal. Right? This AC is equal to FD or a right angle over. Next, hypotenuse. AC is equal to FD. Next, one side. Side BC is equal to given. This is given. BC is equal to ED. So, by RHS criterion, this triangle ABC is congruent to FED. This is one way. Also, if we proved like this side also equal, right? This third one side is also equal, must be equal. So, by triple S also it is congruent. For your best understanding, watch our Congruence of Triangles introduction video. Thank you.